Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Concepts of the values of x for which binomial expansions are valid is the topic of this lecture. An important advice: we should be good to others. Well, binomial expansion, where the first term of the expansion is 1, is valid for these values of x, modulus x less than 1. In modulus x less than 1, the second term of the expansion is used. Let's understand this concept with the help of this example. For the values of x for which this expansion is valid, first make the first term of the expansion 1 and then use modulus x less than 1. In order to make first term 1, we have to take 2 common. So 2, 1 minus 3x upon 2 whole power minus 2. Now this minus 2 power is for both. Finally, we have 1 upon 4 times expansion with power minus 2. Now replace this x by this second term into this inequality and solve inequality for modulus x. We can get the values of x for which this expansion is valid. So we are replacing this x by this minus 3x upon 2. First get this step and then solve this inequality for modulus x. Now bring minus 3 upon 2 outside the modulus. Modulus converts negative into positive. So this is positive 3 upon 2 times modulus. Now solve this inequality for modulus x. For that you need to shift this on other side. So modulus x less than 2 upon 3. So for these values of x, this expansion or this expansion is valid. Or you can say this expansion is valid for these values of x. Another example. State the range of values of x for which this expansion is valid. Since the first term is already 1, so we can directly use this result. Modulus x less than 1. Now replace this x by the second term of this expansion. So second term is positive 2x square. Now solve this inequality for modulus x. First bring 2 outside the modulus. Now shift 2 on other side. Now take a square root on both sides. So the expansion is valid for these values of x. This expansion is valid for these values of x. Another example. Values of x for which this expansion is valid. Second term is 2x. So replace x of this modulus by 2x. Now solve this inequality for modulus x. This means this is the answer, but this means x lies between minus half and half. This means we can substitute any value of x within this range into this expansion, and this expansion will be verified. Another example, we need values of x for which this expansion is valid. The second term of the expansion is minus 3x, so replace this x by minus 3x and solve this inequality for modulus x. Now bring minus 3 outside the modulus. It will become plus 3. So 1 upon 3. So for these values of x, this expansion is valid. Another example. We need values of x for which this expansion is valid. So we need to replace this x by second term of the expansion, which is minus 6x. And we need to solve this inequality for modulus x. Now bring negative 6 outside the modulus and it will become plus 6. So modulus x less than 1 upon 6. Therefore, for these values of x, this expansion is valid. I'm discussing the last part of this question. This question is from November 20, paper 3-2. We need values of x for which this expansion is valid. Second term is 6x. So we need to replace this x by 6x. And we need to solve the inequality for modulus x. So 6 modulus x less than 1. And finally we have modulus x less than 1 upon 6. So this given expansion is valid for these values of x. Last example. We need values of x for which this expansion is valid. In fact, we have done this. I've done this thing. Another question, and this is the last question of this lecture and of this topic. So we need values of x for which the expansion is valid. First we have to make the first term 1. So 2 minus x square whole power minus 2. Now take 2 common. So we have 1 minus x square upon 2 whole power minus 2. Now this will become 2 power minus 2. 1 minus x square upon 2 whole power minus 2. Now see, the first term of the expansion is 1. Now we can use modulus x less than 1 into this expansion for the values of x for which the expansion is valid. So modulus x less than 1 and replace x by minus x square upon 2. And solve this inequality for modulus x. So we have x square 1 upon 2 less than 1. Then we have x square less than 2. And finally we have modulus x less than under root 2. So for these values of x, this expansion is valid. Hope this lecture will help you to understand this concept well. Good luck and Allah Hafiz.